Hey everyone, Brian here. If you're building things on Azure, at some point you will face a situation in which you want to run a piece of code only when something happens. Also, you don't want to manage servers and you don't want to pay for idle compute. So this is exactly where Azure Functions fit. In this video, I'll explain what Azure Functions are with real-world examples, not much theory today. So let's jump in. Alright, so what is an Azure function? So think of an Azure function like code that wakes up when something happens. Maybe a file was uploaded or an HTTP request comes in. It does its job and then it goes back to sleep. And then you are only paying when the function is actually running. So the event happened, it triggers the function app wakes up, runs, and then you are done. And you only pay while this is executing. So let me show you when to use them and more importantly also when not to use them. You can use an Azure Functions when you have event-driven tasks. We already saw that because we need a trigger. Something happens and we need that the code is executed. Also, we can use a function when we have scheduled jobs like the Chrome style automations that we have in Linux, or when we have API endpoints with variable traffic, or finally we have short-lived tasks, less than 10 minutes of execution. And don't use Azure Functions if you have long-running processes, greater than 10 minutes, 15 minutes. There is better platform for this type of job. If you have app that needs constant uptime, this is not suitable. And finally, if you have complex stateful workflows, it's not the best. You can think maybe as durable functions, but this is not the case for this video. So think of Azure Functions like something happens and your code reacts. Azure Functions are code that reacts to something. I'm going to show you 3 scenarios that solve real business problems. So let me show you the architecture of each one. So here's the diagram for each application that we'll be looking today. So let me show you the scenarios for each example. So the first one is invoice processing. So we want that when someone uploads an invoice PDF, we want to extract some data from the PDF and then save that structured data into an Azure SQL database. So the workflow is going to be that the user uploads a PDF into a Blob storage. Blob is going to trigger the Azure function. The Azure function extracts that data searching for certain patterns. And then finally, we have an Azure SQL database to store the data that is defined in the PDF. The second example will be using a timer trigger for the scheduled data sync. So the scenario is that we need to pull current exchange rates from an external API every 5 minutes, every hour, it depends on your needs, and update our pricing database. So this is going to have a cron expression that will be triggered the function. The function will make an HTTP request to an external API, and then we will store the data into an internal storage. In our case, it's going to be a blob storage, but it can be also a database. So finally, the HTTP request, we are going to create an API endpoint without having to manage any servers. And the scenario is that my website or your website has a contact form. And when someone submits, we need to validate the data that is sent there. Send an email, and also we want to save to a CRM, but in our case, we are only storing in an Azure table. The HTTP tree will receive a post request, then this will be triggered the Azure function, and then finally we will have 2 output bindings to send the data in a queue and then also in an Azure table. Let me show you the code of the first example, which I think is the most common use case for Azure Functions. So this is the code. Here we have a Python code, which basically here defines the trigger. We're specifying that every time there is a new blob inside this container called invoices, then this will be triggered. I'm using bindings for input and output. So this is going to use the connection that is defined in the Azure function to connect to the resources. And then I also define via decorators the SQL output. Similarly, I am specifying what is going to be the table, and then also I am specifying what is the connection string. I use the PDF plumber to do that, and then it basically goes and extract the data from the PDF that it's important. Of course, the PDF has to have a format that is already defined, and I have a sample. And then finally, it just sets that data into the database using the output binding that I define here in the decorator. There is also 2 extra helpers to extract patterns and to extract the exact amount. So this was already deployed into Azure. So now let's test this. I will upload a sample invoice into the invoices container, and you will see that this will trigger the function. The function will extract the data, and it will save that data in a SQL database automatically. So let me just upload the sample PDF that I have here. So I will go into the process invoice PDF function. I will go into invocations, And yeah, as you can see, this was the latest execution that I did. Now, if we go to the table that we have, DBO invoices, I will execute. And now we have two entries in this table. So it extracted the data from the PDF and saved it into this table automatically. Now, let me show you the second example, which is the timer trigger, which will retrieve the information from an external API to update our exchange rate table. This is the code for the timer function. The key part here is this run expression, which basically means that this will be executed every 5 minutes. If you have worked with Linux, this should be familiar to you. And also we are defining two output bindings to the same container, which we will keep two JSON, one for the latest and one history for the exchange rates. So we are making an HTTP request to this API so that we get the latest exchange rates for certain currencies, and then we just create that structure, and then here is where we create the JSON, and then we added it into the blob for both the latest one and historical rates. Now let's look at the execution history of fetch exchange rates function so that you see that this has been executed since I started the demo every 5 minutes as my definition of Chrome expression. And this is populating this container exchange rates. This you will see the latest JSON and also a history of all the JSON that has been executed. Finally, let me show you the example 3 to create a REST API without managing any servers, and this will be doing a contact form handler or validator. So here's the code for the function HTTP trigger, and we have in this case two additional outputs, one for queue and another for table. We will send one notification email, so we will store the information in a queue, and then we will keep the records of the users in an Azure table. Also, you can see that this is the HTTP trigger that we define. We are only accepting post methods. This won't work with get. So this is a form validation, so we will be making sure that these three fields are required. If some of them are missing in the request, then we will return an HTTP response with an error. And also we will do the validation for the email address so that it has the add and the proper format. And finally, we create the structured data to send to the Azure table. We create the email, the subject, the message that we get from the request, and we also are passing some internal properties. In this part, we are defining the information that we will send to the email. So we define it here and we will send it in this part. And finally, we return, if everything works, we return an HTTP response with a receive and a thank you. We'll be back to you soon. Now, let me test this function with this sample request. I am passing my name, some email, and a subject, so I should receive a successful response. So as you can see, I get the successful response and the message that I define in the code. So also remember that this is sending a message to a queue and storing this information in the table. So let's look at that. So in this section, I will check the tables first. There is a contact submission table. So I will get the data so that you can confirm that the data has been assigned. So I have done multiple requests. The latest that I did was this. So this is the information. Additionally, I only passed these 4, and these 2 were added in by the code automatically. Similarly, if we go to the queues, we will see an email notification, and then here's the information for the email notification that we need to process. Before we wrap up, let me clarify these concepts. We have seen triggers and bindings in the 3 examples that we saw. So what are they? So remember that the trigger is what starts the function. It can be an HTTP request, a timer, or even more complex stuff like event grid events or service bus messages. So this triggers the function. Then we also saw bindings. Bindings are an easy way to retrieve information from external sources or to put information there without having to manually create the connection to there. So Azure already handles that. So we don't have to specify what is the connection string. Okay, open the connection now. We only specify what we want to connect, and Azure will handle how it is connected. For input bindings, we have how to read from a database, so the authentication to the database is going to happen invisible to us. And similar for output bindings, we have writing to a database. We saw how to write to a database, to a queue, to a blob, and we didn't have to define the connection to those services. The final part that I wanted to discuss is hosting plans comparison, because I think that this will define how your functions are going to be executed. So we have 3 main plans, which is consumption, dedicated, and premium. So for the consumption you pay for execution, it scales automatically, but it has a timeout of 5 to 10 minutes. So if your execution runs for more than that, it will fail. Second, we have a dedicated plan. We use it, in this case, it uses an app service plan. It can be shared with an app service. You have predictable billing because you know it's going to be fixed, and it has the option to be always on. And finally, we have the premium plan, which has pre-warm instances, because remember the function has something called call stars. So if a function is not executed in 2 to 5 minutes, it goes to sleep, and then when it wakes up, it will take 1 to 2 seconds to execute. For that, premium plan has pre-warm instances which don't have that call star. And also the premium plan has VNet integration. All right, let's recap what we covered today. We look at what Azure Functions are: serverless, event-driven code that only runs when something happens. It's reactive code. Something happens, it is executed, and then it goes back to sleep. And we build 3 real examples. We build the invoice extractor, the currency sync, and then the contact form handler. Hopefully this is interesting to you. Thanks for watching, and see you in the next one.